Hello, today we're going to be looking at lesson 8.4, which is percent increase and decrease. And we're going to start by reviewing the formula. The formula for percent change, which is percent increase or decrease, is to find the difference in the two amounts. So we're going to take the larger minus the smaller. And we're going to always divide that by the original number, regardless if it was bigger or smaller. And then at the end, once we do the division, to turn it into a percent, we're going to multiply by 100. And we can determine if it was an increase based on if the number got bigger, or a decrease if the number got smaller. So let's jump right in and try one. So in example 1A, it says find the percent increase or decrease. And just to point out, if it says increase or decrease, you know that your answer must indicate which of the two it was. First, we're going from 8 to 12. So what I'm going to do is take my larger minus my smaller. So I would do 12 minus 8 over the original number, which in this case was 8, because we went from 8 to 12. And so that means that in my numerator I have 4, and in my denominator I have 8. And now I would do 4 divided by 8, and as a decimal I get 0.5. To turn that into a percent, I would multiply by 100. And I noticed that I went from 8 to 12, which was an increase. So my final answer after I multiply by 100 would be a 50% increase. And I would be done. Next, if I take a look at letter B, I see that I'm going from 20 to 17. So I again would take my larger minus my smaller, so it'd be 20 minus 17 over the original number, which in this case was 20. So if I go back to the top from 20 to 17, I can see, of course, that that is a decrease. So now in my numerator, I have 3 divided by 20, which is going to be 0.15, and then I multiply that by 100, giving me a final answer of 15% decrease. So that's the basic type of problem that we're going to see with percent change. It will get a little bit more involved, but that's the basic thing that we're going to look at. So let's take a look at example 2. So it says, on the day before Thanksgiving, there were 120, I'm sorry, it's a little crooked here. There were 120 4D TVs available. After the Black Friday sale, there were only 15 left. What was the percent decrease? So notice that it tells us that it's percent decrease. When that's the case, you don't have to indicate it at the end, but certainly it's okay to do so. We want to think about here again finding the larger minus the smaller. So there were originally 120 TVs, and we're going to subtract that by the amount that are remaining, the smaller number, which is 15. But we're dividing again by the original number. So the original would be how many there were the day before Thanksgiving, which would be 120. So now I'm going to do my subtraction in the numerator. I get 105 over 120. And now I divide 105 by 20, and I get 0.875. Now, to turn that into a percent, I multiply by 100, and I get a final answer of 87.5%. And of course, we said that was a decrease. Okay, in example 3. Jim bought a new video game that was originally $70 that is now 15% off. What is the sale price? So in this one, it is a decrease problem, but we don't necessarily have to use the formula. In fact, it might be slightly easier if we instead just figure out what 15% of that original price would be and then deduct it from the original price to find the sale price. So to do that, we would say, okay, if it's 15% of 70, you could even think about translating this. So 15% of $70 would be in decimal form 0.15. Of means multiply, and then multiply by 70. And we would get 1050. Now that's certainly not our answer, but that's the amount of the deduction. Now I would go back to my original cost of $70 and subtract the 1050 to get an answer of $59.50 as the sale price. Okay, in this next one we have a multi-step problem here. And if you'll notice, it says Abby had 2 coupons for her purchase at Target. The first coupon was for 20% off. The second coupon is for an additional 10% off the sale price. If Abby's purchase was $160, how much will she have to pay after each of her coupons? So this is really a 2-part problem, and this can be commonly mistaken when people think they can just take the 2 percentages and combine them, but that unfortunately is not true. You have to do them separately. The first one is 20%, and then it's 10% additional off of that. So let's begin by finding the 20% of her purchase. So if her total purchase was $160, we could easily find 20% of that by doing the decimal form of 20%. So we're essentially doing 20% of 160, which we think back to our equation method would be 0.2 times 160. And we would end up getting $32. So that means that this is $32 off. So her first sale price, we would have to take the original 160, subtract 32, and we would get an initial sale price of $128. However, we're not finished because then we need to take this number and figure out what the additional 10% off would be. So what we would do now is take 10% of 128, and so this would be 0.1 times 128, which will end up being $12.80, and that's off. But that's off of the sale price, not of the original price, of course. So her new price would be $128 minus the $12.80, which would leave us with $115.20 as her final price. Okay, next, number 5. In number 5, it says, a coat store sells everything at 25% above wholesale price in order to make a profit. If the store purchased a Michael Kors coat for $220, what will the retail price be? So what's important to understand here is retail price is going to be an additional amount that we're adding on, because that's how stores will make profit. They sell the item for more than what they originally bought it for. So in this case, if it's 25% above the wholesale price, we need to figure out what 25% of that original $220 was. So we're going to be translating 25% of 220, and so 25% as a decimal would just be 0.25. Of means multiply, so we multiply by $220, and we end up with $55. Now that is not the price of the coat. That is the additional amount. So it's $55 more that they will actually sell it for. So to get our total price that they're going to retail the coat for, we would take the amount they paid, the wholesale price, $220, plus the $55 additional, and get an answer of $275, and that would be the price of the coat. Okay, in our last question here, this is a little bit more involved, and so we want to make sure we really understand what the question is asking and go through step by step here. So let's begin. It says, Lily and Emily are both traveling with their families to Key West. The trip is 1,260 miles. Lily's family rides at an average of 60 miles per hour. exactly how many hours does it take Lily's family to reach Key West? So we can answer this in a step-by-step strategy here. So this one's not too hard. So I would probably set this up as a proportion, though that's not the only way certainly to do it. But we could start by doing 1260 as the total trip, we know, and the amount of hours that it takes her. So we would say that she can do 1,260 miles in X hours, which we aren't sure of yet. But if we set this up as a proportion, we could set it equal to her speed, which was 60 miles in just 1 hour. And from there, we could cross multiply these. So we would actually get 60x is equal to 1,260. To solve for x, I will divide by 60, and I get an answer of x equals 21 hours. Okay, now I know it's hours because if I look back to my proportion, it was miles over hours, miles over hours. So that's how long it would take Lily's family to reach Key West. Okay, now it says using the graph, find Emily's rate in miles per hour. So Emily's rate is given in a graph form. So what we're going to do is look for a very clear point, and there might be multiple of these, but a very clear point where we can see what her speed is. So for some reason, the first one that stuck out to me was right here, and that was at 3,210, which means that she can go 210 miles in 3 hours. So if I simplify that by dividing by 3, that would tell me that she goes 70 miles per hour. So that is the rate at which Emily's family is traveling. So the next part of the question says, how long does it take Emily's family to get to Key West? Well, we know the distance of the trip already is 1,260 up here. So we're going to do the same sort of problem that we did for Lily, but with her speed. So again, she's going 1,260 miles. And we're trying to figure out the time, so in X hours. And we know her family is traveling at 70 miles per hour. So now I can cross multiply and solve this. So we would get 70x equals 1260. Divide by 70. And we would get an answer of 18 hours. Okay. So now it tells us that Lily's family increases their speed by 15% the next time they go to Key West. So what is Lily's new speed in miles per hour? So what we need to do is go back to Lily, which is all the way up here. She was going 60 miles per hour, and figure out her new speed. So we would do 0.15 times 60 to see how many additional miles she's traveling per hour. And we would get an answer of 9. So that's 9 more. So then I would take the 60 miles per hour she was originally traveling and add 9 more on to get an answer of 69 miles per hour. So now it says, at the time that Emily's family reaches Key West, how many fewer miles does Lily's family travel? In other words, where is Lily's family in the trip? So remember, the time that it takes Emily's family is right here, 18 hours. So because we know the total distance is 1,260 miles, and so that was 18 hours later, now we need to figure out if Lily's family is now traveling 69 miles per hour, where would they be 18 hours into the trip? And so we're going to take their speed, 69 miles, and multiply it by the number of hours. that it takes Emily's family, and we end up getting 1,242 miles into their trip. So they're very close to getting there, but they're not quite there yet, and clearly we can see that their speed was slightly smaller than the speed of Emily's family still, even with the 15% increase. So how many miles more do they have to travel? If we were going to solve that, we would take the total distance of the trip, which is how many miles Emily's family would have traveled at this point, subtract the number of miles that Lily's family has traveled, and we end up getting 18 miles away. So where is Lily's family? They are 18 miles away when Emily's family arrives, based on their increase in speed. Okay, thank you.